Hello there, and welcome to Sleep Science Chronicles. I'm glad you're here. Whatever kind of day you've had, whether it was long or quiet, busy or still, you've made it to this moment. And this moment asks nothing of you. There's no task waiting, no question you need to answer, no place you need to be. You can simply rest, simply listen, and let your thoughts drift wherever they wish to go. Tonight, we're going to spend some time with an old friend, one who has watched over every human being who ever lived, one who has risen above ancient forests and modern cities, above oceans and deserts, above sleeping children and weary travelers finding their way home. The moon. We see it so often that we sometimes forget to truly look at it. That pale glow through the curtains, that silver light on water, that quiet face that has gazed down on earth for longer than life itself has existed here. The moon is so woven into our experience of being alive that imagining its absence feels almost impossible. And yet tonight, that's exactly what we're going to do. We're going to take a gentle journey through everything the moon gives us, everything it quietly does, by imagining, just for a while, what would happen if it simply vanished, not as a catastrophe to worry about, but as a thought experiment, a way of seeing what's always been there, a way of understanding the invisible threads that connect us to that glowing companion in the sky. We'll explore the moon's birth in violence and fire, its stillness and silence, the ancient rhythm of the tides it stirs. We'll wander through moonlit nights and the creatures who depend on that silver glow. We'll trace the moon through human history, through myth and calendar and art, and we'll travel outward to visit other moons circling distant worlds. Some of what we discover will be scientific, some will be poetic, some will be strange and wonderful, but all of it, I hope, will feel like a kind of homecoming, a return to something you've always known, but perhaps never stopped to fully appreciate. You don't need to remember any of it. You don't need to stay awake for the whole journey. If your eyes grow heavy and your thoughts begin to blur, that's perfectly fine. The moon will still be there when you wake. It always is. If these quiet explorations help you unwind or give you a peaceful way to end your day, consider liking and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is breathe, settle in, and let the journey begin. Let's start by simply looking up. The moon appears almost the same size as the sun in our sky. This is one of the most remarkable coincidences in our solar system. The sun is about 400 times larger than the moon, but it also happens to be about 400 times farther away. These two facts cancel each other out almost perfectly, so when we look up, the moon and the sun seem to match. This cosmic accident gives us total solar eclipses, those rare moments when the moon slides precisely in front of the sun and the sky goes dark in the middle of the day. No other planet in our solar system has a moon that creates eclipses quite like ours. It is a gift of geometry, pure chance, and the particular moment in time we happen to exist. The moon drifts about 3.8 centimeters farther from Earth every year. It has been slowly receding since its birth, and it will continue to drift outward for billions of years to come. This means the perfect alignment we see today is temporary on a cosmic scale. In the distant past, the moon appeared much larger, looming enormous in ancient skies. In the distant future, it will appear smaller, and total solar eclipses will no longer be possible. We live in a window of time, perhaps a few 100 million years, when the match is just right. Future beings, if any exist, will never see the moon completely cover the sun the way we can. We only ever see one face of the moon. The same craters, the same dark plains, the same familiar features have greeted every human who ever looked up. This happens because the moon rotates on its axis at exactly the same rate that it orbits Earth, a phenomenon called tidal locking. The moon does rotate, but one full rotation takes the same amount of time as one full orbit, about 27 days. So, the same hemisphere always faces us. The far side, sometimes mistakenly called the dark side, receives just as much sunlight as the near side. It simply faces away from Earth, hidden from our view, until spacecraft traveled there to photograph it. The far side of the moon looks surprisingly different from the near side. When we gaze at the moon, we see large dark patches called maria, the Latin word for seas. Ancient observers thought these might be bodies of water. We now know they are vast plains of ancient volcanic rock, formed when lava flooded the surface billions of years ago. The far side has far fewer of these dark maria. Instead, it is densely covered with craters, giving it a rougher, more battered appearance. Scientists are still exploring why the two hemispheres differ so dramatically. One theory suggests that the near side's crust is thinner, allowing more lava to reach the surface in the distant past. The moon has no atmosphere to speak of. There's no wind, no weather, no sound. If you stood on the lunar surface in a spacesuit, you would experience absolute silence. No rustle of leaves, no distant hum of traffic, no whisper of breeze. Just stillness. This silence extends through time as well. Without wind or water to erode them, features on the moon last for millions, even billions of years. Footprints left by astronauts in the 1960s and 70s are still there, pressed into the fine gray dust exactly as they were made. They will remain for millions of years, long after the civilizations that sent those astronauts have faded from memory. The temperature on the moon swings between brutal extremes. During the lunar day, which lasts about 2 weeks, the surface bakes under unfiltered sunlight, reaching temperatures around 120 degrees Celsius, hot enough to boil water if there were any. During the equally long lunar night, temperatures plummet to minus 170 degrees Celsius or lower, colder than any place on Earth. This happens because there is no atmosphere to hold heat or distribute it across the surface. Each spot on the moon faces the raw furnace of the sun or the freezing void of space with nothing in between. Moonlight is simply reflected sunlight, yet it feels different. The light that reaches us from the moon has bounced off a surface of gray rock and fine dust. The lunar surface reflects only about 12% of the sunlight that strikes it, which is similar to the reflectivity of worn asphalt. And yet, on a clear night, the full moon can be bright enough to read by, bright enough to cast shadows, bright enough to turn a landscape silver. This is not because the moon is particularly reflective, but because it is close, and because our eyes are remarkably sensitive in low light. The moon gives us just enough glow to navigate the night without overwhelming the stars. The color of moonlight is not quite white. Scientifically, it should be almost identical to sunlight, since it is sunlight bounced back to us. But the moon's surface absorbs some wavelengths more than others, and our eyes perceive low-light environments differently than bright ones. The result is that moonlight often seems cooler, bluer, and more ethereal than daylight. Artists and poets have always known this. There is something in the quality of moonlight that feels different from any other illumination. A softness that transforms landscapes into something dreamlike and still. When the moon is full, it rises at sunset and sets at dawn. This perfect opposition means the full moon accompanies us through the entire night, climbing highest around midnight. This rhythm has been part of human experience for as long as there have been humans. The full moon was the ancient nightlight, the lantern that allowed travel and work after dark, the beacon that marked the passage of time. Many cultures developed calendars based on the moon's phases, counting months from one full moon to the next. The word month itself comes from moon. We have been keeping time by that silver clock for thousands of years. The moon appears larger when it is near the horizon than when it is high in the sky. This is an optical illusion, one that has puzzled observers for centuries. The moon is actually slightly closer to us when it is overhead, so if anything, it should appear larger then. But our brains interpret the horizon moon differently, comparing it to trees, buildings, and distant hills, and somehow conclude that it must be enormous. Photographs prove that the moon's size remains constant throughout the night. The illusion persists anyway. Our perception of the moon is shaped not just by light and physics, but by the peculiar workings of the human mind. Sometimes, just before the new moon, you can see the ghostly outline of the moon's dark portion, faintly glowing against the black sky. This phenomenon is called earthshine. It happens because sunlight reflects off the earth, travels to the moon, and then bounces back to us. The moon is being illuminated by light that has already touched our world. When Earth is showing a large bright phase to the moon, such as when we see a thin crescent, the earthshine is strongest. Leonardo da Vinci was among the first to correctly explain this soft glow. It is a reminder that Earth and Moon are always exchanging light, always reflecting each other's presence across the void. The moon was born in violence, almost unimaginable. About 4.5 billion years ago, when Earth was young and still forming, a Mars-sized object struck our planet. This impactor, sometimes called Theia, collided with Earth at a glancing angle, vaporizing rock and flinging vast amounts of debris into space. The energy of the impact was so immense that parts of both Earth and Theia melted and merged, while other material was ejected into orbit. This ring of molten rock and vapor gradually cooled and coalesced. Within perhaps a few thousand years, possibly even less, the debris had gathered itself into a sphere. The moon had been born from catastrophe, rising from the wreckage of two worlds. The giant impact hypothesis explains many of the moon's peculiar features. The moon has a much smaller iron core than expected for a body its size, because the impact blasted away mostly rocky mantle material, while Earth retained most of the iron. The moon's composition is remarkably similar to Earth's outer layers, as if it were made from the same stuff, because it largely was. The moon also orbits in almost the same plane as Earth's equator, which would be unusual if it had been captured from elsewhere. The violence of that ancient collision left signatures that scientists can still read today, written in the chemistry of lunar rocks and the geometry of orbits. In the hours and days after the impact, the sky above Earth would have been unrecognizable. A vast arc of glowing debris stretched overhead, slowly condensing into a new world. The young moon may have formed remarkably close to Earth, perhaps only about 20,000 kilometers away, compared to nearly 400,000 kilometers today. At that distance, the moon would have appeared enormous in the sky, perhaps 20 times larger than it appears now. Earth and moon were born together in fire, two bodies forged from the same disaster, destined to drift slowly apart over billions of years. The moon's surface preserves a record of a violent period called the Late Heavy Bombardment. About 4 billion years ago, the inner solar system was swept by a storm of asteroids and comets. The moon's cratered face bears witness to this era. Without an atmosphere or geological activity to erase them, those ancient scars remain visible today. The largest impacts created the Maria, those dark plains we see when we look up. Molten rock welled up from beneath the surface and flooded the impact basins, creating smooth, dark seas that contrast with the bright, cratered highlands. The moon is a history book written in stone and shadow, recording events that Earth's dynamic surface has long since erased. The moon once had active volcanoes. It is hard to imagine now, looking at that cold, silent surface, but billions of years ago, lava flowed across the lunar plains. The dark Maria are solidified lava flows, some of them hundreds of meters thick. Volcanic activity peaked around 3 to 4 billion years ago and then gradually ceased as the moon's interior cooled. Today, the moon is geologically quiet, though not entirely dead. Occasional moonquakes still ripple through its interior, some triggered by Earth's gravitational pull, others by thermal expansion and contraction as the surface heats and cools. The moon sleeps, but it still trembles in its sleep. The moon is slowly drifting away from Earth, and this drift is connected to the tides. As the moon pulls on Earth's oceans, it creates a tidal bulge, but Earth rotates faster than the moon orbits, so this bulge is always slightly ahead of the moon's position. The bulge's gravity pulls on the moon, giving it a tiny extra boost of energy. That energy comes from Earth's rotation, which means Earth is gradually slowing down. The moon gains energy and spirals outward. This exchange has been happening for billions of years. The moon that once loomed enormous and close is now distant and receding, and the days that were once just a few hours long have stretched to 24. Scientists have recovered samples of the moon and brought them back to Earth. The Apollo missions returned over 800 pounds of lunar rock and soil. These samples revolutionized our understanding of the moon's history. They confirmed the giant impact hypothesis, revealed the moon's age, and showed that the moon has no indigenous water in its rocks, though ice may exist in permanently shadowed craters at the poles. Holding a piece of the moon, a fragment of another world that humans walked upon, remains one of the most extraordinary achievements in our history. Those rocks sit in laboratories today, still yielding secrets, still connecting us to that distant companion. The moon has no global magnetic field like Earth does. Early in its history, it may have had one, generated by a churning liquid core. But as the moon cooled, its core solidified and the magnetic dynamo faded away. Without a magnetic field, the moon's surface is exposed to the solar wind, a stream of charged particles flowing from the sun. Over billions of years, the solar wind has implanted itself into the lunar soil, which is why the samples returned by Apollo contained traces of elements delivered by the sun. The moon's surface is a collector, gathering particles from across the solar system and preserving them in its ancient dust. The lunar dust itself is remarkable and strange. It is not like any dust on Earth. Formed over billions of years by micrometeorite impacts, the dust consists of tiny jagged particles of glass and rock, There is no wind or water to smooth the edges, so the grains remain sharp. This dust clings to everything. Astronauts found it stuck to their suits, their equipment, their skin. It smells faintly metallic. Some said like gunpowder. The dust can damage seals and irritate lungs. Future lunar explorers will need to develop new strategies for managing this pervasive, clinging material. The moon's surface is covered in a fine gray powder that remembers every impact, every moment of violence, ground to fragments over eons of silent time. Now let us turn to one of the moon's most visible gifts, one that has shaped coastlines and ecosystems in human cultures for as long as there have been shores to stand upon: the tides. The moon's gravity reaches across nearly 400,000 kilometers of space and pulls on Earth's oceans. The water on the side of Earth, closest to the moon, feels this pull most strongly and bulges outward toward the moon. But there is also a bulge on the opposite side of Earth, farther from the moon. This second bulge exists because the moon pulls more strongly on the solid Earth than on the distant water, leaving that far side water behind. The result is two tidal bulges on opposite sides of the planet. As Earth rotates beneath these bulges, coastlines experience high tide, then low tide, then high tide again, roughly twice each day. The sun also contributes to the tides, though its effect is smaller than the moon's, despite the sun being far more massive. The sun is so much farther away that its tidal influence is only about half that of the moon. When the sun and moon align during new moon and full moon, their gravitational pulls combine to create especially high and especially low tides, called spring tides. The word spring here refers not to the season, but to the idea of the water springing up. When the sun and moon are at right angles to each other, during the first and third quarter phases, their pulls partially cancel out, creating gentler tides called neap tides. The rhythm of spring and neap tides follows the moon's phases, cycling about twice each month. Tidal ranges vary dramatically around the world. In the open ocean, the tidal range might be less than a meter, barely noticeable. But in certain bays and coastal configurations, tides can be amplified enormously. The Bay of Fundy, between Nova Scotia and New Brunswick, has the most extreme tides on Earth, with ranges that can exceed 16 meters, the height of a 5-story building. The shape of the bay funnels and concentrates the tidal energy. Twice a day, an almost unimaginable volume of water rushes in and out, reshaping the shoreline, revealing vast mudflats, and then swallowing them again. The tides here are a visible reminder of the moon's invisible hand. Tides do not simply move water up and down. They move it horizontally as well, creating tidal currents that can be remarkably powerful. In narrow channels and straits, tidal currents can flow faster than many rivers. These currents carry nutrients, transport larvae, mix water layers, and shape the distribution of marine life. Many sea creatures have evolved to exploit tidal currents, drifting with the flow to conserve energy or timing their movements to the rhythm of the rising and falling water. The horizontal movement of the tides is a vast circulatory system, stirring the coastal oceans twice each day. The timing of the tides shifts by about 50 minutes each day. This happens because the moon is not stationary. It orbits Earth, moving eastward through the sky. Each day, Earth must rotate a little extra to catch up with the moon's new position. So high tide arrives about 50 minutes later each day, cycling through all hours over the course of a month. Coastal communities have always known this rhythm. Fishermen, clam diggers, and sailors have learned to consult tide tables to know when the water will be high enough to float a boat or low enough to walk the flats. The moon sets the schedule, and the ocean follows. Tides have been shaping coastlines for billions of years. The constant movement of water erodes rock, transports sediment, and builds new landforms. Tidal flats, estuaries, salt marshes, and barrier islands are all sculpted by the daily rhythm of rising and falling water. Over millions of years, the tides have helped carve the continents themselves, widening river mouths, creating harbors, and building the deltas where rivers meet the sea. The shoreline you see today is the product of countless tidal cycles, each one a small brushstroke in a painting that spans geological time. Tidal pools are windows into a world shaped by the moon. These small pools of water, left behind when the tide retreats, are miniature ecosystems. Sea anemones, starfish, crabs, snails, and tiny fish inhabit these pools, adapted to survive both underwater and exposed to air. Life in a tidal pool demands resilience. Temperatures swing as the sun beats down and the water evaporates. Salinity rises and falls with rain and evaporation. Oxygen levels fluctuate. The creatures here are experts at enduring change, their rhythms tuned to the moon's pull. When the tide returns, the pool reconnects to the sea, refreshed and renewed, ready for another cycle. The tides play a crucial role in ocean mixing. As tidal currents flow across the seafloor, they stir up sediments and create turbulence that mixes water layers. This mixing brings nutrients from the deep to the surface, where sunlight allows phytoplankton to grow. Phytoplankton are the foundation of the ocean food web, and many of the richest fishing grounds in the world are found in areas with strong tidal mixing. The moon, through its gravitational pull, helps fertilize the seas. Without tides, the oceans would be more stratified, with nutrients trapped in the depths and surface waters less productive. Ancient humans noticed the connection between the moon and the tides long before they understood gravity. Coastal peoples around the world developed sophisticated knowledge of tidal patterns, knowing when to fish, when to gather shellfish, when to set sail. The Greek philosopher Posidonius, in the 1st century BCE, wrote about the relationship between the moon and the tides. But it was not until Isaac Newton, in the 17th century, that the mechanism was explained. Newton's law of universal gravitation showed how the moon's mass, reaching across space, could pull on Earth's waters and create the rhythm that had been observed for millennia. The tides became one of the first great triumphs of gravitational physics. Imagine now if the moon were to vanish. What would happen to the tides? The oceans would not become entirely still. The sun would still exert its tidal pull, creating a gentle rise and fall. But solar tides are only about half as strong as lunar tides. The dramatic tidal ranges we see today would diminish significantly. The Bay of Fundy's 16-meter tides might shrink to a fraction of their current size. Coastlines would change. The intertidal zone, that rich band of life between high and low water, would narrow. Species adapted to the rhythm of the tides would find their world altered. Tidal flats, those vast expanses of mud and sand, revealed twice daily, would shrink or disappear. These flats are critical feeding grounds for shorebirds, nurseries for fish, and habitats for countless invertebrates. Without strong tides to expose them, the flats would remain submerged. The birds that migrate thousands of miles to feed on these flats would find their fuel stations diminished. The fish that spawn in shallow tidal waters would have fewer places to breed. The food web that depends on tidal rhythms would need to reorganize itself, a process that might take thousands of years. Estuaries, where rivers meet the sea, are among the most productive ecosystems on Earth. Tides push salt water upstream and pull fresh water out to sea, creating a mixing zone that supports enormous biological diversity. Mangrove forests, salt marshes, and seagrass beds thrive in these tidal environments. Without the moon's tides, the mixing would be weaker. Salinity gradients would shift. The delicate balance that supports these ecosystems would be disturbed. Some species would adapt, others would not. The estuaries that have nourished human civilizations for thousands of years would become quieter, less dynamic, less alive. The tidal friction that slows Earth's rotation would also change. The moon is the primary driver of this friction, and without it, Earth would slow down much more gradually. Days would still lengthen over time due to the sun's tidal influence, but the pace would be different. The long-term future of Earth's rotation would unfold along a different path. This might seem like a small thing, but over billions of years it would matter. The length of the day affects climate, ocean circulation, and the rhythms of life itself. The moon has been shaping the pace of our planet since it was born. And yet, even without the moon, life would continue. The oceans would still move, still teem with creatures, still crash upon the shores. The changes would be profound, but not catastrophic. The thought experiment is not meant to frighten, only to illuminate. The tides we take for granted, the rhythm that has accompanied every generation of humans, is a gift of the moon. When we watch the water rise and fall, we are watching gravity at work across the void, a dance between two worlds that has been going on for 4.5 billion years. Let us turn now to something less visible, but perhaps even more important. The moon is a stabilizer. It keeps Earth steady on its axis, and this steadiness has made our world a gentler place for life. Earth is tilted on its axis by about 23.5 degrees. This tilt is why we have seasons. When the northern hemisphere tilts toward the sun, it experiences summer. When it tilts away, winter comes. The southern hemisphere experiences the opposite. This tilt has remained relatively stable for millions of years, wobbling only slightly over long cycles. The stability of our tilt is one of the reasons Earth's climate has been hospitable enough for complex life to evolve. The moon's gravity is what keeps this tilt stable. Without the moon, Earth's axis would be free to wander. Gravitational tugs from the sun and the other planets would pull on Earth's equatorial bulge, causing the tilt to change dramatically over time. Computer simulations suggest that without the moon, Earth's axial tilt could vary anywhere from 0 degrees to more than 80 degrees over millions of years. 0 degrees would mean no seasons at all, with the equator always receiving the most direct sunlight. 80 degrees would mean extreme seasons, with each pole pointing almost directly at the sun for part of the year. Mars offers a glimpse of what this instability looks like. Mars has 2 tiny moons, Phobos and Deimos, but neither is large enough to stabilize the planet's tilt. Over the past several million years, Mars's axial tilt has swung wildly, ranging from about 15 degrees to more than 35 degrees, possibly even more in the distant past. These changes in tilt have driven dramatic climate shifts, with ice caps growing and shrinking, dust storms intensifying, and surface conditions varying enormously. Mars today is a frozen desert, but its chaotic axial history has left scars across its surface. Earth's moon is unusually large compared to its planet. Among the rocky planets of the inner solar system, only Pluto and Charon have a more similar size ratio, and Pluto is now classified as a dwarf planet. Mercury and Venus have no moons at all. Mars has only its tiny captured asteroids. Earth alone has a companion massive enough to exert a significant gravitational influence. This appears to be relatively rare among planets, at least in our solar system. The stability the moon provides may be one of the factors that made Earth suitable for the long, slow development of complex life. The tilt of Earth's axis is not perfectly constant, even with the moon. Over a cycle of about 41,000 years, the tilt oscillates slightly, from about 22 degrees to about 24.5 degrees. This slow wobble is one of the Milankovitch cycles, named after the Serbian scientist who first calculated their effects on climate. These gentle variations in tilt, along with other orbital changes, have influenced the timing of ice ages over the past few million years. But these variations are small, just a few degrees. Without the moon, the swings would be enormously larger and far more chaotic. Imagine Earth without the moon, its axis free to tilt wildly over millions of years. During periods of low tilt, the poles would receive very little direct sunlight, remaining frozen year-round. The equator would dominate, with most of the planet's warmth concentrated in a narrow band. During periods of extreme tilt, the poles would experience months of continuous scorching sunlight, followed by months of total darkness. Temperatures would swing from one extreme to another. Ice would advance and retreat across vast distances. The climate chaos would make it difficult for ecosystems to establish themselves or for species to adapt. The stability of Earth's axis has allowed life to develop in a relatively predictable environment. Organisms can evolve strategies based on consistent seasonal patterns. Migration routes can be established. Breeding cycles can be synchronized. Agriculture, which depends on predictable seasons, would be nearly impossible on a world with a wildly varying tilt. Human civilization as we know it has been built on the assumption that spring will follow winter, that summer will bring warmth, that the pattern will hold. The moon, silently orbiting overhead, has made that assumption valid. This does not mean that life could not exist on a planet with an unstable axis. Life is remarkably adaptable. Organisms might evolve to cope with changing conditions, migrating to follow favorable climates, or entering dormancy during extreme periods. But the development of complex, multicellular life, and eventually intelligent life, seems to benefit from stability. The long stretches of consistent conditions allow evolution to build on itself, layer upon layer, without having to start over after each climate catastrophe. The moon may have given life on Earth the time it needed to become what it is today. Earth's axial tilt also affects the distribution of climates across the planet. Because of the tilt, the tropics receive the most direct sunlight over the course of a year, while the poles receive the least. This creates climate zones, from tropical rainforests to temperate woodlands to polar ice caps. These zones provide diverse habitats, allowing many different forms of life to flourish. Without a stable tilt, these zones would shift and blur. Ecosystems would be in constant flux. The rich tapestry of climates that makes Earth so biologically diverse might never have developed. The moon also affects the length of Earth's day, though this influence operates over much longer timescales. Tidal friction, caused by the moon's gravitational pull on the oceans, gradually slows Earth's rotation. Billions of years ago, when the moon was much closer, Earth rotated much faster. Days may have been only 6 hours long. The moon's gravity has been breaking Earth ever since, and the days have been lengthening. 100 million years ago, a day was about 23 hours. 100 million years from now, it may be 25 hours. The pace of change is glacially slow, but it is real. As Earth's rotation slows, the moon drifts farther away. This is a consequence of the conservation of angular momentum. The energy lost from Earth's rotation is transferred to the moon's orbit, pushing it outward. The moon is currently receding at about 3.8 centimeters per year, roughly the rate at which fingernails grow. This slow spiral outward will continue for billions of years. Eventually, Earth and Moon will reach a state of mutual tidal locking, where the same face of Earth always points toward the Moon, just as the same face of the Moon always points toward Earth. This will happen far in the future, long after the Sun has begun to die. In the earliest days after the Moon's formation, when it orbited much closer, the tides on Earth were enormous. Walls of water may have swept across the young planet's surface, driven by a moon that loomed huge in the sky. The days were short, the tides were violent, and the world was a very different place. Some scientists speculate that these powerful tides may have played a role in the origin of life, concentrating organic molecules in tidal pools, cycling them through wet and dry conditions, providing the energy and environment for the first self-replicating molecules to form. The moon, born from destruction, may have helped create the conditions for life to begin. The relationship between Earth and Moon is a slow dance, a gravitational conversation that has been going on for 4.5 billion years. The moon steadies our axis, slows our rotation, stirs our seas, and lights our nights. In return, Earth holds the moon in its orbit, a partnership born from the chaos of a cosmic collision. Neither world would be quite the same without the other. The moon we see tonight is both a remnant of violence and a guardian of stability, a paradox written in stone and light. Let us leave the physics of tilt and rotation for now and turn to something softer, the light of the moon and the creatures who live by it. The full moon is about 400,000 times dimmer than the sun, and yet it can transform the night. Under a full moon, you can see colors, though muted. You can walk without stumbling. You can recognize faces from a distance. The landscape takes on a silver quality. Shadows become pools of ink, and the world feels both familiar and strange. This is not much light by daytime standards, but to eyes adapted to darkness, it is more than enough. The moon turns the night into something navigable, something almost welcoming. Human eyes have two types of light-sensitive cells. Cones detect color and work best in bright light. Rods detect only shades of gray but are far more sensitive in low light. Under a full moon, both systems are active, though rods dominate. This is why moonlit scenes appear somewhat colorless, washed in silver and blue. The cones are working at the edge of their ability, picking up hints of color, but not the full spectrum. The result is a world that looks different from daylight, softer and more mysterious. A world seen through the particular limitations and capabilities of human vision. The spectrum of moonlight is almost identical to sunlight because moonlight is sunlight reflected. And yet, it does not feel the same. Part of this is intensity. Our eyes and brains process very bright and very dim light differently. Part of it is psychological. we associate the moon with night, with sleep, with dreams. And so the light it casts carries those associations. There is also a slight shift in color. The moon's surface absorbs some wavelengths more than others, and this gives moonlight a very subtle warmth that our eyes often interpret as cool or blue when surrounded by darkness. The moon paints the night in its own quiet palette. For most of human history, moonlight was the only illumination available after sunset, apart from fire. The full moon meant visibility, safety, and the possibility of travel or work. Many cultures timed activities to the lunar cycle, harvesting by the light of the harvest moon, hunting by the hunter's moon. The moon extended the usable hours of the day, a gift of time that shaped how people lived. Even today, in places without artificial light, the full moon changes everything. The night becomes accessible in a way that the dark of the new moon never is. Animals have been navigating by moonlight for far longer than humans. Many species have evolved to take advantage of the moon's illumination, while others have learned to fear it. The relationship between moonlight and animal behavior is complex, woven into predator-prey dynamics, mating rituals, and migration patterns. The moon is not just a light in the sky. It is an ecological force, shaping the lives of creatures who have never looked up and wondered what it is. Nocturnal predators often hunt more successfully under moonlight. Owls can see well in very low light, but even they benefit from the moon's glow. Lions on the African savanna have been observed hunting more frequently on darker nights when prey cannot see them approaching. But their overall success rate may actually be higher on moonlit nights when they can spot and coordinate attacks on prey more easily. The balance between visibility and concealment shifts with the moon's phases, and predators must adapt their strategies accordingly. Prey animals, for their part, often become more cautious during the full moon. Many small mammals reduce their activity when the moon is bright, staying hidden in burrows or under vegetation. The risk of being spotted by a predator outweighs the benefits of foraging. Studies of rodents have shown that they spend less time in open areas during full moon nights, preferring the safety of shadows. The moon imposes a rhythm of risk on the landscape, a cycle of danger and relative safety that pulses through ecosystems every month. Some creatures have turned moonlight into a cue for the most important moments of their lives. Coral spawning is one of the most spectacular examples. Once a year, often a few nights after the full moon, entire coral reefs release clouds of eggs and sperm into the water simultaneously. The timing must be precise. If individuals spawn at different times, the eggs and sperm will miss each other in the vast ocean. The moon provides a reliable signal that all the corals can detect, synchronizing a reproductive event across hundreds of miles of reef. The sea fills with drifting clouds of life, all triggered by the light of the moon. The grunion, a small fish found along the California coast, also times its spawning to the moon. These fish ride the highest tides onto sandy beaches, where females burrow into the sand to lay their eggs. The males fertilize the eggs, and both return to the sea with the receding wave. The eggs incubate in the sand, protected from aquatic predators, and hatch when the next high tide washes over them. This entire cycle depends on the spring tides, which occur around the new and full moon. The grunion have entrusted their reproduction to the moon's gravitational pull. Dung beetles navigate by moonlight, using the pattern of polarized light to travel in straight lines. On moonless nights, they can still navigate using the Milky Way, but the moon provides a much brighter reference. Studies have shown that dung beetles wearing tiny blindfolds become disoriented, rolling their dung balls in circles rather than straight lines. The moon is their compass, a beacon that allows them to escape from competitors and predators as quickly as possible. Even the humblest creatures have found ways to use the moon's light. Moonlight affects the vertical migration of zooplankton in the ocean, one of the largest daily movements of biomass on Earth. Every night, tiny creatures rise from the depths to feed near the surface, then descend again before dawn to avoid predators. On bright moonlit nights, many zooplankton stay deeper, reducing their exposure to visual predators like fish. This behavior ripples through the food web, affecting everything from the smallest larvae to the largest whales. The moon reaches down into the dark ocean and influences the rhythms of life in ways that are still being discovered. Some flowers open only at night, and many of these are pollinated by moths drawn to pale blossoms glowing in the moonlight. Night-blooming jasmine, evening primrose, and moonflowers have evolved to attract nocturnal pollinators. Their white or pale petals reflect moonlight, making them visible in the darkness. Their fragrances intensify after sunset, filling the night air with sweetness. These flowers have built their reproductive strategies around the moon, blooming when its light is strongest, offering nectar to creatures who fly by silver glow. Moths themselves have a complicated relationship with light. The classic explanation for their attraction to flames and lamps is that they evolved to navigate by the moon. By keeping the moon at a constant angle, a moth can fly in a straight line. Artificial lights confuse this system, causing moths to spiral inward toward the source. Whether or not this explanation is entirely correct, it speaks to how deeply moonlight is woven into the lives of nocturnal insects. The moon was their guide long before humans invented fire. Badgers, those secretive diggers of the night, adjust their activity based on lunar brightness. On moonlit nights, badgers may forage for shorter periods or stay closer to their sets. They are wary animals, and the increased visibility of bright nights makes them cautious. Other burrowing mammals show similar patterns. The moon imposes a schedule on the underground world, determining when it is safe to emerge and when it is better to wait in darkness. Birds migrate at night, and many use the moon as a navigational aid. The moon provides a reference point, a bright landmark in the sky that helps birds maintain their heading. On overcast nights, when neither moon nor stars are visible, migrating birds may become disoriented, sometimes flying in circles or landing to wait for clearer skies. The moon is part of the vast navigational toolkit that birds have developed over millions of years, alongside the stars, the Earth's magnetic field, and landmarks on the ground below. Sea turtles hatching on beaches instinctively head toward the brightest horizon, which under natural conditions is the ocean reflecting moonlight and starlight. Artificial lights from coastal development can disorient them, leading hatchlings away from the sea and toward roads and buildings. Conservation efforts now include shielding lights near nesting beaches to preserve the darkness that guides these ancient creatures to safety. The moon's reflection on water is a beacon that has led baby turtles to the sea for over 100 million years. Now imagine the moon vanished and the nights grew darker. Starlight alone would remain. On a clear, moonless night, the stars provide some illumination, but far less than the full moon. You might still see the outline of trees against the sky, but colors would vanish entirely. Shadows would lose their definition. Walking without a light source would become genuinely difficult. The night would feel deeper, more absolute, in a way that modern humans, surrounded by artificial light, rarely experience. For animals adapted to low light, the change might be manageable. Many nocturnal species can see well even in near total darkness. But for those that rely on moonlight for hunting, navigation, or timing their behavior, the adjustment would be significant. Predators that hunt by sight might find darker nights more challenging. Prey that currently hides during full moons might find new freedom in the unbroken darkness. The balance of power between hunter and hunted would shift. Coral spawning events, timed to the moon for millions of years, would lose their synchronizing signal. Corals might still spawn, triggered by other cues like water temperature or day length, but the precision would be lost. Without a reliable signal that all individuals can detect, spawning might become scattered, reducing fertilization rates and threatening the survival of reefs already stressed by other pressures. The moon's disappearance would ripple through marine ecosystems in ways that are difficult to predict. Migratory birds that use the moon for navigation would need to rely more heavily on other cues. The stars would still be there, and birds have multiple navigational systems. But the loss of the moon would remove one tool from their kit, making long journeys slightly more difficult. On cloudy nights, when neither moon nor stars are visible, the darkness would be complete. Migration might become more hazardous, with more birds losing their way or colliding with obstacles they cannot see. For humans, the change would be psychological as well as practical. We have been looking up at the moon for as long as we have been human. It is woven into our stories, our calendars, our sense of time. The moon has been a symbol of constancy, a companion that rises and sets, waxes and wanes, but is always there. An empty night sky, missing that familiar glow, would feel like a loss, a companion gone silent. We would adapt, as we always do. But something would be missing, and we would feel it. The moon in human culture is not just an astronomical object. It is a presence, a character, a symbol rich with meaning accumulated over thousands of years. Almost every culture on Earth has mythology surrounding the moon. In Greek tradition, the moon was associated with Selene, a goddess who drove her silver chariot across the night sky. The Romans called her Luna, a name that still echoes in words like lunar and lunatic. In Hindu mythology, Chandra is the moon god, associated with the mind, emotions, and the passage of time. The Japanese Shinto tradition speaks of Tsukuyomi, the moon god who governs the night. The Chinese honor Chang'e, a goddess who lives on the moon with a jade rabbit, a figure celebrated during the Mid-Autumn Festival. Across the world, the moon has been personified, worshipped, and woven into stories that explain the cosmos and our place within it. The moon has been associated with femininity in many cultures, perhaps because of the approximate correspondence between the lunar cycle and the menstrual cycle. Both are roughly 29 days, a coincidence that ancient peoples could not help but notice. The moon's phases, waxing and waning, also suggest cycles of fertility, growth, and renewal. Many goddesses associated with the moon are also connected to childbirth, nurturing, and the rhythms of life. This association is not universal, as some cultures see the moon as masculine, but it is widespread enough to have shaped art, religion, and symbolism across millennia. The word month comes from moon. Before clocks and calendars, humans marked time by the moon's phases. A new moon to the next new moon is about 29.5 days, and this became the basis for the month in many early calendars. The Islamic calendar is purely lunar, with 12 months that drift through the seasons over a cycle of about 33 years. The Jewish and Chinese calendars are lunisolar, combining lunar months with adjustments to keep them aligned with the solar year. Even the Gregorian calendar we use today, though based on the sun, preserves the month as a unit, a vestige of our lunar timekeeping past. The full moon has been given many names, often reflecting the activities or natural events associated with that time of year. In many Native American traditions, the full moon of January is called the wolf moon, when wolves were heard howling in the cold. February's full moon is the snow moon. The harvest moon, perhaps the most famous, is the full moon closest to the autumn equinox, when its light allowed farmers to work late into the night, bringing in crops. These names vary by culture and region, but they share a common thread. The moon was a calendar, a marker of seasons, a reminder of what needed to be done. The moon has inspired art for as long as humans have been making images. Prehistoric cave paintings may include representations of the moon. Ancient pottery, sculpture, and jewelry feature lunar symbols. In more recent centuries, painters have captured the moon in countless works, from the serene moonlit landscapes of Caspar David Friedrich to the swirling night sky of Vincent van Gogh. Musicians have sung about the moon in every genre, from classical compositions to folk ballads to modern pop songs. The moon is a muse that never tires, always available to any artist who looks up. Poets have found endless meaning in the moon. It represents beauty, longing, solitude, the passage of time, the constancy of nature amid human change. In Japanese poetry, the moon is a central image, appearing in countless haiku and tanka as a symbol of impermanence and beauty. In Western literature, the moon often accompanies lovers, illuminating secret meetings and whispered confessions. Shakespeare filled his plays with moonlit scenes, from the balcony in Romeo and Juliet to the enchanted forest in A Midsummer Night's Dream. The moon is a mirror that reflects whatever meaning we bring to it. The moon has also been associated with madness, a connection preserved in the word lunatic. Ancient observers believed that the full moon could unbalance the mind, causing strange behavior and mental disturbance. This belief persisted for centuries and has not entirely disappeared. Hospital staff, police officers, and teachers sometimes claim that full moons bring more emergencies, more erratic behavior, more chaos. Scientific studies have generally failed to confirm any connection between the moon's phases and human behavior, but the belief endures. The moon's power over our imagination is real, even if its power over our minds is not. Werewolf legends connect the full moon to transformation, the idea that a person can become a beast under its light. This mythology appears in many cultures, though the specific creature varies. The common thread is the moon as a trigger, a force that unlocks something hidden within. These stories may reflect anxieties about human nature, the fear that beneath our civilized surface lurks something wild and uncontrollable. The moon, with its monthly cycle and its pale, watchful face, became the symbol for this fear, the moment when the mask slips and the beast emerges. The moon has influenced architecture and urban planning. Many ancient structures are aligned with lunar events. Some stone circles and temples were built to track the moon's movements, predicting eclipses or marking important points in the lunar cycle. The alignment of windows, doorways, and sacred spaces with moonrise or moonset suggests that architects considered the moon's light and position when designing buildings. Even today, the moon affects how we think about outdoor spaces, as landscape designers consider how moonlight will fall on gardens and pathways. Farmers have long planted and harvested according to the moon. The practice of planting by the moon phases persists in some communities, with different crops sown during waxing or waning moons. The scientific evidence for this practice is weak, but the tradition runs deep. Almanacs still publish planting guides based on lunar phases, and many gardeners swear by them. Whether or not the moon actually affects plant growth, the belief that it does connects modern farmers to practices that stretch back thousands of years. Fishing communities often time their activities to the moon. Fish may be more active during certain phases, or tidal patterns created by the moon may concentrate fish in predictable locations. Fishermen pass down knowledge of which moon phases bring the best catches, knowledge accumulated over generations. The moon is a silent partner in the harvest of the sea, influencing when nets are cast and when boats return to port. The moon has been a navigation aid for as long as humans have traveled. Before compasses and GPS, sailors used the moon to determine their position and course. The moon's position relative to the stars changes predictably, and skilled navigators could use these positions to calculate longitude. The method was complicated and required precise measurements, but it worked. The moon helped guide ships across oceans, connecting distant lands, long before modern technology made navigation easy. Timekeeping itself owes much to the moon. The division of time into months preserves the lunar cycle, even in calendars that no longer track the moon directly. The concept of a week may also have lunar origins, with the 7 days corresponding roughly to the phases of the moon, though this is debated. The moon gave early humans a way to mark time beyond the simple alternation of day and night, a larger rhythm that organized festivals, rituals, and social life. Religious calendars often depend on the moon. The date of Easter in Christianity is calculated based on the moon, falling on the first Sunday after the first full moon following the spring equinox. Ramadan in Islam begins with the sighting of the new crescent moon. Jewish holidays like Passover and Sukkot are tied to specific points in the lunar cycle. The moon is woven into the sacred calendars of billions of people, determining when they fast, feast, pray, and celebrate. The moon has witnessed every human drama, every civilization rising and falling, every war and peace and revolution. It hung over ancient Babylon and imperial Rome, over medieval cathedrals and Renaissance piazzas. It has risen over battlefields and wedding feasts, over births and funerals, over moments of triumph and despair. The moon connects us to everyone who has ever lived, a shared reference point across all of human history. When we look up and see the moon, we see the same light that illuminated the faces of our ancestors, stretching back to the very first humans who walked the earth. Imagine the moon vanished, and with it, this cultural connection. Calendars would need to be recalculated. Religious observances tied to the moon would lose their anchor. Festivals that have been celebrated for thousands of years would need new systems to determine their dates. The change would be practical, a matter of adjusting calculations and traditions. But it would also be symbolic, a severing of the thread that connects us to the past. The moon is a living artifact, a piece of the ancient world that we can still see and touch with our eyes every night. Without it, the night sky would be beautiful, but it would be missing something irreplaceable. The moon has also shaped our sense of cycles and time. The monthly rhythm of waxing and waning gives us a unit of time between the day and the year, a measure that fits human activities well. A project that takes a month feels different from one that takes a week or a year. The moon's phases provide natural checkpoints, moments to pause and assess. The new moon is a beginning, the full moon a peak, the waning moon a time of release and preparation. These rhythms have influenced how people think about planning, growth, and change for thousands of years. The arts would lose a muse. Poets would still write about night, about stars, about darkness and light. But something specific would be gone, a particular quality of light, a particular symbol with millennia of meaning. Future artists would not know the experience of walking under a full moon, of seeing the world transformed by that silver glow. They would not understand references to the moon in older works, except as historical curiosities. A thread of meaning running through all of human culture would be cut. And yet humans are adaptable. We would create new symbols, new calendars, new ways of marking time. The stars would remain, and they too have inspired art and mythology and navigation. The loss would be real, but it would not be the end of culture or meaning. The thought experiment reveals how much the moon has given us, but it also reveals our resilience. We would mourn, and then we would adapt, as we always have. Let us turn now to the moon's influence on life itself, beyond culture, beyond what humans have made of it. The moon has shaped biology, evolution, and the rhythms of living things in ways we are still discovering. The circulunar rhythm is a biological cycle tied to the moon's phases, lasting about 29.5 days. Many marine organisms display these rhythms, timing their reproduction, feeding, or behavior to specific points in the lunar cycle. These rhythms are not simply responses to moonlight. They persist even in laboratory conditions in constant darkness, suggesting that organisms have internal clocks tuned to the moon. The mechanism is not fully understood, but it appears that life has internalized the moon cycle, carrying it within cells and genes. The bristleworm, Platinares dumerili, has become a model organism for studying circulunar rhythms. These worms swarm to mate at specific times relative to the moon's phase, a behavior that continues even in the laboratory. Researchers have identified genes and neural circuits involved in this timing, revealing how the moon's cycle is written into the worm's biology. The moon reaches down into the molecular machinery of life, setting clocks that run even in the absence of moonlight. Many species of fish spawn in synchrony with the moon. Groupers gather in massive spawning aggregations timed to specific lunar phases. Rabbitfish along coral reefs release eggs and sperm in coordination with the moon. The timing ensures that eggs are dispersed by tidal currents at the optimal moment, increasing the chances that larvae will reach suitable habitat. For these fish, the moon is not just a light in the sky. It is a signal that triggers the most important moment in their reproductive lives. Horseshoe crabs, ancient creatures that have changed little in hundreds of millions of years, time their spawning to the highest tides. During spring tides around the new and full moons, horseshoe crabs gather on beaches along the Atlantic coast to mate. Females dig shallow nests in the sand where they lay thousands of eggs. Males cluster around, fertilizing the eggs. The high tides deposit the eggs at a level that will be reached again 2 weeks later. allowing the eggs to develop in moist sand before hatching. This ritual has been repeating for longer than dinosaurs have existed, always in rhythm with the moon. Some researchers have investigated whether humans have circulunar rhythms. The menstrual cycle averages about 29 days, close to the lunar cycle, and this has led to centuries of speculation about a connection. Most scientists believe the similarity is coincidental. Human menstrual cycles vary significantly between individuals and are not synchronized with the moon. However, some studies have suggested subtle correlations between sleep patterns and the lunar cycle, with people sleeping slightly less around the full moon. The evidence is mixed, and the effects, if real, are small. The moon's influence on human biology remains uncertain. Sleep studies have attempted to measure whether people sleep differently under the full moon. Some studies have found that people take longer to fall asleep, sleep fewer minutes, and report lower sleep quality around the full moon, even in controlled environments without moonlight exposure. Other studies have failed to replicate these findings. The question remains open. If the moon does affect human sleep, the mechanism is unknown. It may be that ancient rhythms, evolved when moonlight was the only night illumination, still echo faintly in our biology. Or it may be coincidence and expectation shaping the results. The belief in lunar influence on human behavior persists despite scientific skepticism. Hospital staff often report busier emergency rooms during full moons. Police officers claim more disturbances and arrests. Teachers describe more unruly classrooms. These anecdotal reports are consistent and widespread, but studies examining hospital admissions, crime rates, and emergency calls have generally found no correlation with the moon's phases. The persistence of the belief may reflect confirmation bias. We remember the busy full moon night and forget the quiet ones. The moon's reputation for causing chaos may be more powerful than its actual influence. Animals in zoos have been observed to change behavior with the moon's phases. Primates may be more active or vocal during full moons. Predators may prowl more restlessly. These observations are difficult to interpret, as captive animals are exposed to artificial light and other confounding factors. But the patterns suggest that the moon's influence on behavior is not limited to wild animals. Even in artificial environments, traces of lunar rhythm may persist. Plants may also respond to the moon, though this is less well documented. Some researchers have found that certain plants grow faster during particular lunar phases, while others have found no effect. The lunar gardening traditions practiced by many cultures suggest a long history of belief in the moon's influence on agriculture. Whether this reflects genuine biological rhythms or cultural tradition is still debated. The moon's light is dim, but plants are remarkably sensitive to light. It is not impossible that millions of years of evolution have tuned some plants to the moon cycle. The intertidal zone, that narrow band between high and low tide, is perhaps the most thoroughly moon-influenced habitat on Earth. Every creature living here must cope with the twice-daily rhythm of flooding and exposure. The timing of tides, controlled by the moon, determines when these animals can feed, when they must hide, when they are vulnerable to predators from land or sea. Intertidal life is life lived by the moon's clock every day for billions of years. Some scientists have speculated that life itself may owe its origins to the moon. The powerful tides of early Earth, when the moon was much closer, may have created unique environments where chemistry could occur, Tidal pools concentrating organic molecules, cycling between wet and dry, heated and cooled, might have provided the conditions for the first self-replicating molecules to form. This is speculative, and other theories of life's origin do not require the moon. But it is intriguing to imagine that the moon, born from violence, may have helped nurture the fragile beginnings of life. The moon has been a constant presence throughout the entire history of life on Earth. Every organism that has ever lived has lived under its light, influenced by its tides, perhaps shaped by its rhythms in ways we do not yet understand. The moon is not separate from life. It is woven into the fabric of the living world, a partner in the long story of evolution. To remove the moon would be to remove a thread that runs through everything. Now, let us leave Earth behind for a while and venture outward. The moon is not the only moon in our solar system. There are hundreds, perhaps thousands of moons orbiting other planets, and each one has its own story. Jupiter has at least 95 known moons, a miniature solar system orbiting a single giant planet. The four largest, discovered by Galileo in 1610, are worlds unto themselves. Io, Europa, Ganymede, and Callisto have been studied by spacecraft and telescopes for decades, and each one holds surprises that challenge our understanding of what a moon can be. Io is the most volcanically active body in the solar system. Its surface is constantly being reshaped by eruptions, with plumes of sulfur and silicate rock shooting hundreds of kilometers into space. The source of this activity is gravitational. Io is caught in a tug-of-war between Jupiter's immense gravity and the gravitational pulls of the other large moons. This flexing of Io's interior generates enormous heat, keeping the moon's insides molten and driving the ceaseless volcanism. Io's surface is painted in yellows, reds, and oranges by sulfur compounds, a world that looks almost too vivid to be real. Europa, slightly smaller than our moon, is covered in a shell of ice, but beneath that ice lies something remarkable. Evidence strongly suggests that Europa harbors a global ocean of liquid water, kept warm by the same tidal heating that powers Io's volcanoes. This ocean may contain more water than all the oceans of Earth combined. The ice shell is crisscrossed with cracks and ridges, perhaps formed as the ice flexes over the moving water below. Europa has become one of the most promising places in the solar system to search for life beyond Earth. Where there is liquid water and energy, life as we know it becomes possible. Ganymede is the largest moon in the solar system, bigger than the planet Mercury. If it orbited the Sun instead of Jupiter, we would call it a planet. Ganymede has its own magnetic field, the only moon known to possess one, generated by a liquid iron core deep beneath its icy surface. Like Europa, Ganymede may have a subsurface ocean, though buried deeper beneath thicker ice. Its surface shows both ancient, heavily cratered terrain and younger, grooved regions where the ice has been tectonically reshaped. Ganymede is a world of layers: ice over ocean over rock over metal, a complexity that rivals any planet. Callisto is the outermost of the Galilean moons and the most heavily cratered object in the solar system. Its surface is ancient, largely unchanged for 4 billion years. Unlike the other Galilean moons, Callisto shows little sign of internal activity. It may have a subsurface ocean, but if so, it lies deep beneath a thick, cold crust. Callisto is a time capsule, its battered face recording the bombardment that shaped the early solar system. Standing on Callisto, You would look up and see Jupiter looming enormous in the sky, while beneath your feet lies a record of cosmic violence stretching back to the beginning. Saturn's moons are equally diverse, and one stands out as perhaps the strangest world we have ever explored. Titan, larger than Mercury, is the only moon in the solar system with a thick atmosphere. That atmosphere is denser than Earth's, composed mostly of nitrogen with traces of methane and other organic compounds. The surface of Titan is hidden beneath an orange haze, but radar and infrared observations have revealed a landscape of lakes and seas, mountains and dunes. The catch is that these features are not made of water. Titan's lakes are filled with liquid methane and ethane. Rain falls on Titan, but it is hydrocarbon rain pooling in basins and carving river channels through the icy bedrock. The surface temperature on Titan is about minus 179 degrees Celsius, far too cold for liquid water. But some scientists speculate that beneath Titan's icy crust, there may be a water ocean, similar to Europa's. The surface environment, with its complex organic chemistry, has also drawn interest from astrobiologists. Could life exist in Titan's methane seas, using entirely different chemistry than life on Earth? It seems unlikely by our current understanding, but Titan reminds us that the universe may have more imagination than we do. Enceladus, a small moon of Saturn only about 500 kilometers across, has become one of the most exciting targets in planetary science. In 2005, the Cassini spacecraft discovered that Enceladus is shooting geysers of water vapor and ice particles into space from cracks near its south pole. These plumes contain not just water, but also salts, organic molecules, and molecular hydrogen, all signs of hydrothermal activity beneath the ice. Enceladus has a subsurface ocean in contact with a rocky core, and that ocean may have the ingredients and energy needed for life. A tiny moon, bright white and streaked with blue ice, has become a place where we might find the answer to one of humanity's oldest questions. The rings of Saturn are accompanied by dozens of small moons, many of them embedded within the rings themselves or shepherding the ring edges. These moonlets interact gravitationally with the ring particles, creating gaps, waves, and intricate patterns. Some moons, like Pan and Atlas, have swept up ring material and developed strange equatorial bulges that make them look like flying saucers. The dance between Saturn's moons and rings is a gravitational symphony, with each small body influencing the others in subtle and beautiful ways. Uranus and Neptune, the ice giants of the outer solar system, have their own collections of moons. Miranda, a moon of Uranus, has one of the most bizarre surfaces ever seen. Enormous fault canyons called coronae slice across its face, some of them 20 kilometers deep. The surface looks like it was assembled from mismatched pieces, with different terrains jumbled together. One theory suggests that Miranda was shattered by an impact and then reassembled, its fragments falling back together in a chaotic jumble. Another theory proposes that intense tidal heating drove geological activity that reshaped the surface. Either way, Miranda is a puzzle, a small world with a violent and mysterious past. Triton, Neptune's largest moon, orbits backward. While almost all large moons orbit in the same direction their planet rotates, Triton moves the opposite way. This retrograde orbit strongly suggests that Triton was not born around Neptune, but was captured, probably from the Kuiper Belt, the region of icy bodies beyond Neptune's orbit. Triton may be a cousin of Pluto, a wanderer that strayed too close to Neptune and was caught. Its surface is young and geologically active, with geysers of nitrogen gas erupting from beneath the ice. Triton is a captured world, a visitor from the outer reaches of the solar system, now locked in orbit around a giant planet. Pluto and its largest moon, Charon, form almost a double dwarf planet. Charon is about half the size of Pluto, and the two bodies orbit a common center of gravity that lies between them in empty space. They are tidally locked to each other, so the same face of Pluto always sees the same face of Charon, and vice versa. Standing on Pluto's near side, Charon would hang motionless in the sky, never rising or setting, a frozen companion locked in eternal stillness. The Pluto-Charon system is a reminder that the definition of moon is somewhat arbitrary. These two bodies are partners, bound together at the edge of the solar system. Mars has two tiny moons, Phobos and Deimos, named after the Greek gods of fear and terror. These small, irregular bodies are almost certainly captured asteroids, their surfaces dark and heavily cratered. Phobos is only about 22 kilometers across, Deimos even smaller at around 12 kilometers. Phobos orbits so close to Mars that it rises in the west and sets in the east, completing an orbit in less than 8 hours. Tidal forces are slowly dragging Phobos closer to Mars, and in perhaps 50 million years, it will either crash into the planet or be torn apart to form a ring. Mars's moons are temporary companions, destined to disappear. Our moon is unusual among all these moons. It is large relative to the planet it orbits, fifth largest of all moons in the solar system, yet it orbits a relatively small rocky planet. Mercury and Venus have no moons at all. Mars has only tiny captured asteroids. Among the rocky planets, only Earth has a true companion, a substantial moon born from its own substance. This may be rare in the universe. Moons are common, but large, stabilizing moons around rocky planets may be exceptional. The presence of a large moon may have been important for the development of life on Earth. The stability it provides to our axial tilt, the tides it stirs, the light it casts, even its role in the early bombardment history of the inner solar system, all may have contributed to making Earth habitable. If large moons around rocky planets are rare, then planets like Earth, with stable climates and rich ecosystems, may also be rare. Our moon may be one of the reasons we are here to wonder about it. Scientists have speculated about what kind of moons might exist around exoplanets, worlds orbiting distant stars. Some giant exoplanets have been detected in the habitable zones of their stars, where liquid water could exist. If these planets have large moons, those moons might themselves be habitable. An Earth-sized moon orbiting a Jupiter-like planet, warmed by the star and perhaps by tidal heating, might have oceans, atmospheres, and the potential for life. We have not yet detected exomoons with certainty, but they almost certainly exist, waiting to be discovered. The search for exomoons is challenging because they are small and faint compared to their parent planets, which are themselves small and faint compared to their stars. But techniques are improving, and several candidate exomoons have been identified. If confirmed, these discoveries would expand our understanding of where in the universe the conditions for life might be found. Moons may be as important as planets in the search for habitable worlds. Now, let us return to Earth and to the humans who first reached outward to touch another world. On July 20th, 1969, two human beings stepped onto the surface of the moon. Neil Armstrong and Buzz Aldrin became the first of their kind to stand on another world. while Michael Collins orbited above in the command module. The moment was watched by hundreds of millions of people around the world, the largest audience for any event in human history up to that time. Armstrong's words as he stepped onto the surface have become immortal, a recognition that this small step was also a giant leap, a threshold crossed that could never be uncrossed. 12 people have walked on the moon, all of them American astronauts, all of the men, all between 1969 and 1972. They came from different backgrounds and had different personalities, but they shared an experience that no other humans have had. They stood in a place with no air, no sound, no life, and looked up at Earth hanging in the black sky, a blue and white marble impossibly beautiful and impossibly far away. Each of them was changed by the experience, though they described it in different ways. Some became more spiritual. Others became more environmentally aware. All of them carried the moon with them for the rest of their lives. The Apollo astronauts left more than footprints on the moon. They planted flags, placed scientific instruments, and drove lunar rovers across the dusty surface. They also brought back samples, over 800 pounds of lunar rock and soil from 6 landing sites. These samples have been studied for more than 50 years and continued to yield new discoveries. The rocks confirmed theories about the moon's origin and history, revealing that the moon was once molten, that it formed from debris blasted off Earth, and that it has been geologically dead for billions of years. The samples are stored in climate-controlled vaults, preserved for future generations, who may have questions we cannot yet imagine. The retroreflectors left on the moon by Apollo astronauts are still in use today. These are arrays of mirrors designed to reflect laser light directly back to its source. Scientists on Earth fire lasers at these reflectors and measure the time it takes for the light to return. This allows the distance between Earth and Moon to be measured with extraordinary precision, down to a few millimeters. These measurements have confirmed that the Moon is drifting away from Earth, helped test Einstein's theory of general relativity, and revealed subtle wobbles in the Moon's motion. Half a century after they were placed, these small devices continue to do science. The experience of being on the Moon was strange beyond words. The gravity is only 1/6 of Earth's, so astronauts could leap high into the air with little effort, though their bulky suits made movement awkward. The horizon curved noticeably closer than on Earth because the Moon is smaller. There was no atmosphere to scatter light, so the sky was black even during the day, and stars would have been visible if the astronauts' eyes had been adapted to the dark. The silence was absolute, broken only by the sounds inside the spacesuit. The surface was covered in fine gray dust that clung to everything, smelled faintly metallic, and tasted like gunpowder according to those who accidentally ingested it. The Earth, seen from the Moon, is about 4 times larger than the Moon appears from Earth and shines about 50 times brighter. It hangs in the lunar sky, rotating slowly, its cloud patterns swirling, its continents recognizable. The photograph known as Earthrise, taken by Apollo 8 astronaut William Anders in 1968, showed Earth rising above the lunar horizon and became one of the most influential images ever made. It helped spark the environmental movement by showing our planet as a fragile, isolated world, beautiful and alone in the darkness. The Moon gave us a new perspective on ourselves. The last humans to walk on the Moon were Eugene Cernan and Harrison Schmitt of Apollo 17 in December 1972. As Cernan climbed the ladder to re-enter the lunar module, he spoke words meant to mark the moment, expressing hope that we would return in peace and hope for all mankind. Then the hatch closed, the engine fired, and humans left the lunar surface for what has now been over 50 years. The footprints remain undisturbed in the airless stillness, waiting. Several nations and private companies are now planning to return humans to the moon. NASA's Artemis program aims to land astronauts, including the first woman and first person of color to walk on the moon, within the coming years. China has an active lunar exploration program, with robotic missions and plans for crewed landings. India, Japan, and the European Space Agency are also involved in lunar missions. After half a century of absence, the moon is once again becoming a destination. The reasons for returning are both scientific and practical. The moon's south pole, where permanently shadowed craters may contain water ice, is of particular interest. Water on the moon could support future explorers, providing drinking water, oxygen, and hydrogen for rocket fuel. Lunar bases could serve as stepping stones for missions to Mars and beyond. The moon could become a laboratory, an observatory, and a training ground for the deeper exploration of the solar system. After using the moon as a symbol and a destination for so long, we may finally begin to use it as a resource and a home. The moon also preserves a record of solar system history that has been erased from Earth. The constant bombardment of asteroids and comets, the solar wind that streams from the sun, the cosmic rays that rain down from distant stars, all have left their marks on the lunar surface. Earth's atmosphere and geological activity have erased these records on our own world, but the moon's surface is a cosmic archive, storing information about the past 4 billion years. Scientists studying the moon are studying the history of the solar system itself. Future explorers may establish permanent bases on the moon, perhaps in lava tubes, natural tunnels carved by ancient volcanic flows. These tubes could provide shelter from radiation, temperature extremes, and micrometeorites. Underground habitats on the moon might one day house hundreds or thousands of people, living and working on another world. Children might be born on the moon, the first humans to know Earth only as a light in the sky. The moon, which has watched over Earth for so long, might become a place where Earth is watched over in return. Robotic missions continue to explore the moon even now. China's Chang'e program has landed rovers on both the near and far sides, returning samples and studying the lunar surface in unprecedented detail. India's Chandrayaan missions have mapped the moon from orbit and attempted landings. Private companies have sent or are planning to send their own landers, carrying scientific instruments, technology demonstrations, and even commercial cargo. The moon is becoming busier than it has been since Apollo, a destination once again, rather than merely a memory. The far side of the moon, hidden from Earth, offers unique advantages for astronomy. Radio telescopes placed there would be shielded from the electromagnetic noise of Earth, able to detect faint signals from the early universe that are drowned out by our planet's broadcasts. A telescope on the lunar far side might observe the cosmic dark ages, the period before the first stars ignited, listening for whispers from the beginning of time. The moon could become a window to the universe, its silence turned to advantage. For all our missions and ambitions, the moon remains a place of profound stillness. There is no wind to stir the dust, no sound to break the silence, no change except the slow rain of micrometeorites, and the gradual fading of footprints over millions of years. The moon is patient. It has been waiting for 4.5 billion years, and it will continue to wait long after the last human has looked up at it. Our visits are brief flickers in the moon's long existence, moments of activity in an eternity of calm. The moon has no life of its own, but it has been touched by life from Earth. The microbes that may have survived on equipment left behind, the DNA in the artifacts, and human waste discarded by astronauts. Even the simple fact that living beings have stood on its surface and breathed in sealed suits all connect the moon to the web of life on Earth. The moon is no longer entirely sterile, if it ever was. It carries with it now traces of the living world it has watched over for so long. Imagine standing on the moon, in one of those quiet places where no human has ever been. The gray dust stretches to the horizon. The black sky holds the brilliant sun and countless stars, and there, above the horizon, hangs Earth, glowing blue and white, swirled with clouds, turning slowly, alive with weather and light. Everyone you have ever known or heard of lives on that small sphere. Every human drama, every love and loss, every triumph and tragedy is happening there in the distant light. The moon offers perspective, a view of home that makes clear how small and precious our world truly is. Now imagine the moon vanishing. The lunar base is gone, the footprints erased, the retroreflectors suddenly absent. The scientific instruments would fall silent. The water ice in the polar craters would be lost. The archive of solar system history would disappear. But more than that, the possibility would be gone. The dream of standing on another world, of looking back at Earth from a place beyond it, would become harder to realize. The moon has been humanity's first stepping stone. Without it, the path outward would be steeper and longer. The moon is close enough to reach, but far enough to feel like a journey. It is familiar enough to seem friendly, but strange enough to inspire wonder. It is dead enough to be safe, but interesting enough to be worth exploring. In all the universe with its countless worlds, the moon is uniquely ours. Not ours to own, but ours to know, ours to visit, ours to gaze upon on any clear night. The moon is the companion that makes us a two-world species, even if only barely, even if only for now. Let us now return to Earth, return to this moment, and gather the threads of all we have explored. The moon has been with us from the beginning. Before humans existed, before mammals, before dinosaurs, before fish crawled onto land, before life itself emerged from the primordial seas, the moon was there. It watched the first cell divide, the first creature breathe, the first eye open to see the light. It has been the one constant in a world of endless change, rising and setting, waxing and waning, silent and patient, above a planet that churns with life and death and transformation. Every ancestor you have ever had, stretching back through unbroken generations to the very first humans, looked up and saw the same moon. The light that falls on your face tonight fell on the faces of people who lived 10,000 years ago, 50,000 years ago, 100,000 years ago. They did not know what the moon was. They made up stories to explain it. Stories of gods and goddesses, of rabbits and maidens, of chariots and hunters. But they felt its presence, as you do now. The moon connects you to every human who has ever lived. The atoms in your body were forged in stars that died long before the sun was born. Some of those atoms drifted through space for billions of years before finding their way into the cloud of gas and dust that collapsed to form our solar system. When that great collision happened, when Theia struck the young Earth and the moon was born, some of those atoms were blasted into orbit while others remained on Earth. Your body contains atoms that were present at the moon's creation. You are made of the same stuff as the moon, rearranged by 4.5 billion years of chemistry and biology into something that can look up and wonder. The moon has no life, no movement, no change except the slow accumulation of dust and the patient work of gravity. And yet it has shaped the living world more profoundly than almost any other force. The tides that stirred the early oceans, the stable axis that allowed seasons to be predictable, the light that guided nocturnal creatures and human travelers alike, the calendar that organized human societies, the symbol that inspired art and myth and meaning. The moon has been a silent partner in the story of life, never speaking, never acting, simply being there, and in its being, changing everything. Tonight, somewhere on Earth, the tide is rising. Water is creeping up beaches, filling tide pools, lifting boats at anchor. Somewhere else, the tide is falling, revealing sand and rock that will soon be covered again. This rhythm has been repeating since before there were beaches, before there were boats, before there were creatures to notice. The moon pulls and the water follows, and the rhythm continues. It will continue tonight, tomorrow, and for billions of years to come. Tonight, somewhere on Earth, a coral is preparing to spawn. Chemical signals are building inside it, tuned to the moon's phase, waiting for the moment when millions of eggs and sperm will be released into the warm water. The coral does not know why it waits. It does not know there is a moon. But somewhere in its cells, a clock is ticking. A clock set by the moon's light filtering through the water, and when the time is right, the coral will answer. Tonight, somewhere on Earth, a moth is navigating by moonlight. It holds the pale glow at a constant angle, flying straight across fields and forests, following an ancient instinct written into its tiny brain. The moth does not understand optics or astronomy. It simply flies, guided by a light that has guided its ancestors for millions of generations. The moon asks nothing in return for this service. It simply shines. Tonight, somewhere on Earth, a child is looking up at the moon for the first time with real curiosity. Perhaps she is asking a parent what it is, why it glows, why it changes shape. Perhaps she is simply staring, lost in wonder, feeling something she cannot name. That wonder is one of the oldest human experiences. It connects her to every child who has ever looked up at the night sky and felt small and amazed, and somehow comforted by the presence of that gentle light. The moon does not care about us. It is rock and dust without thought or feeling, and yet it has been the most faithful companion our species has ever known. It has never abandoned us, never disappointed us, never failed to appear when the clouds part. It has been there for every first kiss under moonlight, every soldier far from home looking up and knowing that the same moon shines on the people he loves, every sailor using its light to find the way. The moon has witnessed everything and judged nothing. It simply shines. If the moon vanished tonight, we would survive. Life would adapt. Cultures would change. New calendars would be written. New symbols would emerge. New ways of telling time would develop. Humans are resilient. We have survived ice ages and plagues and catastrophes beyond imagining. The loss of the moon would be a blow, but not a fatal one. The earth would continue to spin, the sun would continue to rise, and life would find a way to carry on. But something would be lost that could never be replaced. The night sky would feel emptier, darker, lonelier. The tides would become a memory, their rhythm faded to a gentle pulse. The stories and myths built around the moon would become historical curiosities, tales of something that once was. The word month would lose its meaning, a fossil of a world that no longer existed. And on clear nights, when we looked up at the stars, there would be an absence where something familiar once hung, a hole in the sky shaped like an old friend. The thought experiment ends here. The moon has not vanished. It is still there right now, somewhere in the sky above you or below the horizon, waiting to rise. It will be there tomorrow and the next day and for billions of years to come, the companion that has watched over Earth, since before there was anyone to watch over, is still on duty, still silent, still faithful. We have traveled far tonight. We have journeyed to the moon's violent birth, watched the debris coalesce into a new world, felt the tides rise and fall under its gravitational pull. We have stood on an earth with a wobbling axis and imagined the chaos of seasons unmoored. We have walked through moonlit forests with the creatures who hunt and hide by silver light. We have traced the moon through human culture, through myth and calendar and art, through the minds of poets and the calculations of scientists. We have visited other moons around distant worlds, seen geysers erupting from ice and volcanoes painting a world in sulfur. We have stood with the astronauts who first set foot on lunar soil and looked back at the Earth hanging in the black sky. And through it all, the moon has been our subject and our companion. The thought experiment of its absence was only a way of seeing what has always been there. Sometimes we need to imagine losing something to understand what it means to have it. You are lying here now, perhaps in darkness, perhaps with a faint light nearby. Outside your window, the world continues its slow rotation. The moon is somewhere lit by the sun, reflecting that ancient light back toward Earth. Even if you cannot see it, even if clouds cover the sky or walls block your view, the moon is there. It has been there your whole life. It will be there tomorrow. The iron in your blood was forged in a star that exploded before the sun was born. The calcium in your bones was made in the same way. The oxygen you breathe was created in the hearts of massive stars and scattered across the galaxy in their deaths. You are made of star stuff, as Carl Sagan famously said, and so is the moon. The same cosmic processes that built your body built that pale light in the sky. You and the moon are cousins, separated by 4.5 billion years of different paths, but sharing the same origin in the death of ancient stars. When you look at the moon, you are looking at a piece of Earth's history, a fragment of our planet's violent youth preserved in the sky. You are looking at the reason our world has stable seasons and rhythmic tides. You are looking at a symbol that has meant something to every human culture that has ever existed. You are looking at the first destination humans ever reached beyond Earth, and perhaps the first place we will establish a permanent presence among the stars. But you are also just looking at the moon. That is enough. You do not need to know its history, or its science, or its meaning to feel something when you see it. The moon is beautiful, and beauty needs no explanation. It is there, and we are here. And for a little while, we share the same moment in a vast and ancient universe. The night is quiet now. The facts and wonders we have explored are settling like dust on a still surface. You do not need to hold on to any of them. They will be there if you want to find them again, waiting in books and memories and the silent archive of your sleeping mind. For now, all you need to do is rest. The moon will continue its orbit while you sleep. It will drift a tiny fraction of a centimeter farther from Earth tonight, continuing a journey that began billions of years ago. The tides will rise and fall on distant shores. Somewhere, a creature will hunt by moonlight. Somewhere, a poet will search for words to describe what the moon makes them feel. The world will go on and the moon will watch, as it has always watched, as it always will. If you happen to still be awake, you are welcome to continue to the next video. There are more quiet journeys waiting, more gentle facts, more soft places to rest your thoughts. But there is no hurry. The videos will be there whenever you want them, just as the moon will be there whenever you look up. For now, let your breath slow. Let your shoulders release the last of the day's tension. Let your thoughts drift like clouds across the face of a patient moon. You have done enough today. You have carried your share of the world's weight. Now it is time to set that weight down, to let the darkness hold you, to let the quiet in. The moon is shining somewhere right now. Perhaps a child is seeing it for the first time. Perhaps a traveler is using it to find the way home. Perhaps someone you love is looking up at the same moment. And for an instant, you are connected by that ancient light, even if you do not know it. Sleep well. Dream softly. And when you wake, the moon will still be there, faithful as ever, waiting in the sky like an old friend who has never left and never will. Good night.